Aliasing means uh, a line appearing. Oh, wait a second. Camera focus is gone, I guess. Yeah, line appearing, except horizontal, okay? Except horizontal or vertical, okay? I guess you understand this, right? So a line appearing zigzag or jagged due to discrete nature of pixels, jagged due to discrete nature of pixels. Mm, wait a second. Discrete nature of pixels. Discrete nature of pixels due to bad algorithm. Uh, let's say high resolution images. Mm, let's say hardware limitations. Hardware limitations. Hardware limitations. Uh, hardware limitations when zoom in or out images, okay, is called your aliasing, right? Like what is resolution? Like in this computer, how many pixels are there? Pixels means one light bulb, okay? Like, like have you seen your old computers? If you look closely, there are some square grid type patterns, okay? And even if you see your street lights or some lights, you would actually see that some bulbs are like, if you see digital clock in, like your workplace, or a train station or something, you would notice that if you look closely, there are lights turning on and off, and that makes your number. Like, let's say you want 10, so this would light up, then this would light up sketcher, so like that, this makes your one, like that. So these lights light up and make your picture. So this is called your pixel. Like, this is one element of a picture. So when you draw straight diagonal line, let's say, so what happens is, it might look jagged, like this, like this, like this, let's say, like this, like this, like this, because these are pixels are separate, they're not a continuous stuff, okay? So making a line would be tough here. So that's what aliasing says. And what is anti-aliasing? I will talk about that. Let me change my marker, I guess. Yes. So what is anti-aliasing? Obviously, this is your problem, that your soft hardware is problem, or your your algorithm is a problem. That's why the picture is looking jagged. Now what happens is, we would do anti-aliasing. Anti-aliasing means deceiving the eye, deceiving the eye, the human eye, or let's say the eye, by smarter algorithms. So what is resolution? The pixels I told you, if you increase that pixels in a per area, so that would be your resolution, because that won't look separate or discrete, or box type pattern. Okay, so deceiving the eye by smart algorithms or high resolution hardwares to make appear line smooth, taking higher processing time. Yo, one person came to stream and he left. Have a nice day. Bye, see ya. So high processing time, taking high processing time, uh, CPU power, okay, and storage is called anti-aliasing. Okay, so what do you know is this is your problem, that your image looks jagged or not smooth, rough. So in anti-aliasing you just fool your eye by making the dots much more closer. Okay, so when you do that, so it looks continuous. Let's say I make this, if I add more dots in between, so it much more looks like a complete line, right? If I keep increasing the dots, it becomes one line. So that's what anti-aliasing does. Now, deceiving the eye with smart algorithms or high resolution hardware to make appear lines smoother, taking high processing time, CPU power and storage is anti-aliasing. Now, what is the techniques? So there is pre-filtering, which has weighted, unweighted. Yo, what's up? Welcome to the stream, bro. Welcome to the stream. Really appreciate your visit. What's up? What's up, brother? What's up? So this is unweighted. So what does this mean? I would tell you, okay? And post filtering. By the way, pre-filtering also means area sampling. And your post filtering means post filtering is also called as super sampling. Super sampling. Also, there are some types in this, which is called zero line width, zero line, I guess, zero width line, I guess. Zero. Wait a second, I have to give some space, I guess. And let's see, zero line width. Then there is your finite line width, finite line width, something like that, I guess. And then there is pixel weightage. Okay, pixel weightage. And there is also another technique called pixel phasing that we'll talk later, because it is not much relevant in your syllabus, I guess. Pixel phasing. Okay, so this is also there, but I guess we will talk about it later. Okay, here, pixel phasing. Okay, so we will talk about this later. Now we are focusing on our weighted pre-filtering. Pre-filtering is it it changes. Wait a second, I should give some space, I guess. Let's see. First, changes intensity of light in pixels. So that's what you see in your stations, your train stations or something. Like there is lighting, digital clocks or something. I told you, we for displaying a number, we erase some lines and we keep some lines like that. So what happens is whatever light is there, that highlights and becomes your number, looks like a number. Like let's say 1040 or 1030, then your 10 looks like that. Okay, how we light the pixels, according to that they make a pattern. Okay, now what I would do is weighted, unweighted. Okay, so what happens in weighted is uh, it uh, it lights up, it lights up pixels where lines pass through. Okay, but if overlap, okay, if the lines overlap, equal pixel intensity of both pixels. Okay, intensity to both. So the like uh, the lines doesn't look smooth here, much smoother. Oh sorry, this is unweighted by the way. Yo, what's up? Thanks for the like, bro. Really appreciate it. Really appreciate it. Thanks for coming, bro. Really appreciate your visit. What's up? What's up, bro? Come on, the chat section, bro. Oh, thanks for the emojis, bro. Thanks for the heart emojis. Really appreciate your visit. Thanks for coming. Yo, come on, the chat section, bro. We can yap and interact, bro. Yay, Boo fan. I5J says, I'm BCTD. I can't communicate right now. So, okay, I'm because today I can't communicate right now. What happened, bro? What's up? What happened? What's going on? Why can't you communicate? What happened, bro? You okay, man? So, in what happens in weighted is it favors the center. Favors. What happened, bro? Yeah, Buthan. What's up? What's up? What's up? What happened, bro? Why can't you communicate? What happened? You okay, brother? So it favors pixels. Okay. Uh, okay, busy. Okay. Yeah, Buthan I5J says I'm busy. Okay, BC. Okay, gotcha. Come on, bro. How would I know? BC has many meanings. Even, trash meanings too. Like, how would I know that? Sorry, bro. I didn't know that. Thanks for the enlightenment, bro. I'm busy. I'll go out with my parents next minute, or I'm gonna get cooked. Yeah, no, bro. Obviously, bro. You Asian, bro? You Asian? If you're Asian, yeah, your parents will cook you, man. I know that. Best of luck. Have fun. At least try to have fun if you can, wherever you are going. Yebu fan, I5J says, I'm Asian. Yeah, then best of luck. So, what is your parents' favorite weapon to, thrash up, thrash you up, Which is their favorite weapon? Slippers, sticks. Okay, so Yebu fan, I5J says, bye. Yo, bye, bro. Thanks for coming. Really appreciate a visit. Glad to see you, man. Grateful for your interaction. See ya next time. Have a nice day. Bye. So it favors central pixels. Okay, so like towards the center. Okay, the more the pixel is towards the center, it will favor it. It favors central pixels more, lighting with high intensity. Okay, intensity. extreme areas, extreme areas away from center, away from center, get low intensity. Okay, so what's the difference is, so weighted means, so as you see the word weighted, so it gives weightage or it favors something, it is biased. Okay, and unweighted, it is unbiased. Like we everyone love freedom, equality, which never exists in our true world. But yeah, there would be differences, or let's say discriminations. But yeah, in ideals we do talk about equality. So yeah, in unweighted you give equality, but it is in graphics it is actually primitive version of the things, because if you give equal weightage to everything, the shades won't look perfect, or shades won't look smoother. Okay, when you give it weightage, like center is more highlighted and extremes are much lesser highlighted, then yeah, it looks much more, you know uh, it gets much more clarity. And what happens here is, in super sampling or post filtering, what do we do here? Here we divide pixels. Wait a second. Divide pixels into high resolution, high resolution, high resolution subpixels. Okay, subpixels. Oh my god, I don't even have space to write it now. Okay, I'm gonna shift downwards, I guess. Zero line width. Huh? So what this post filtering does is it uh, mm okay, it divides it divides it divides pixels into high resolution subpixels. Okay, high resolution subpixels. Then zero line width we are talking about, right? Width. So what happens here? What happens here? Tell me. In zero line width, what happens is, it is the version of unweighted. Like it is type of unweighted. Okay, so if line if it falls if it if line falls, actually, if line falls, okay, let's say if line falls into multiple subpixels, intensity increases. Okay, now what is the finite line width? Okay, so okay, finite line width. So what it does is finite line width. It means if lines fall, uh, so it it thinks line as a thick bar. As a thick bar. More inside of polygon, it is more intensity. Okay, now there is a pixel weightage, right? Pixel weightage. So now what we do here is, in pixel weightage what happens, it treats subpixels with a Gaussian filter, a Gaussian variation, the filter is Gaussian, with Gaussian filter, it treats subpixels with a Gaussian filter, multiplying lines hitting subpixels subpixel. So it treats subpixels with a Gaussian filter, multiplying lines hitting subpixel. With a factor. So it treats subpixels with a Gaussian filter. Yo, what's up? 4 people, 5 people in the stream, bro. What's up? What's up? Welcome to the stream, bro. Thanks for coming. Really appreciate your visit. Glad to meet y'all. Really grateful to interact with y'all. Come on, the chat section, bro. What's up? You can ask me anything, or we can yap and interact. Come on, the chat section, bro. Chat section is open, bro. So what we do in pixel weightage is it treats subpixels with a Gaussian filter, multiplying lines hitting subpixels with a factor favoring center. So more lines, more subpixel, so more subpixel, more intensity. Okay, more intensity. So yeah, so that's what happens with a factor favoring. So 8 people in the stream. Yo, what's up? What's up? So more subpixel means more intensity. So it creates smoother lines. Okay, it creates smoother. Come on, bro. That section, bro. Smoother lines. So what happens is in pixel phasing, we don't do maths. We don't do math and intensity adjustment. We don't care about intensity of pixels. Okay, we shift display device like electron gun, that is electron gun to draw smoother lines. Here we go. What's up? Yo, we did this. And everyone is gone till now. Wow. That's crazy. Oh, someone is there. What's up? What's up? Welcome to the stream, bro. Thanks for coming. Really appreciate a visit. Come on, the chat section, bro. Yeah. Oh, 4 people, bro. Yeah, what's up? You can take screenshot notes, and I'm gonna now zoom in. Guess. I guess it is visible till now, right? Now this part. Okay, this part. Then we go for this part. As it is visible. Now I'm gonna explain. Okay. So aliasing means when a line appears zigzag or jagged. Also, I should check like with the original definition if it is correct. I have to match with the reference. Let me check real quick so I don't say any wrong things before I, before I confirm. I should check with the reference I have, with the notes I have. Wait a second, okay? What I have here is, yeah, it divides pixel into high resolution. Yes, done with that. If line falls into multiple pixels, intensity increases. Yes, that is correct. It thinks a line as a, yes, thick bar. More inside of polygon, more intensity. Yes, correct. Yes, let's go. So my definitions are correct. Okay, let's go. I mean, I have reduced the grammatical parts. I have made it much simpler, but in more layman language. It is not much in scientific language. Okay, but it is correct, I guess. So, according to the reference I am following. So, aliasing means a line appearing zigzag or jagged due to, and except horizontal and vertical lines. Horizontal and vertical lines are simpler to draw, but let's say image outline, let's say diagonals or circle outline, they're gonna look jagged if your hardware limitations are there, or your algorithm is bad. Okay, when you zoom in or zoom out of images, because it is already adjusted, but if you zoom in or zoom out, if you scale the image, then obviously the pixels you have, those would break or something like that, because of discrete nature of pixels. Because pixels aren't like continuous objects. They're paths of the, they're elements of an image. Like if you see, I told you right now, like if this is a phone screen, there are tiny light bulbs here. Okay, many bulbs, and some semiconductor diode or a switch. There are multiple switches according to your touch instruction. These on and off, and this light ons and offs. And what happens here is it turns on and off. And what happens is some lights go away, some remains. So an image is formed by the pattern. They get highlighted. Okay, so that's how your image is formed. So this is not a continuous line. It is actually a wait a second. I guess my marker is not working, so I'm gonna do this. So these are not continuous line. These are dots, separate dots. These are not continuous. So if I light this up, let's say you have to see this diagonals. So it can be a little jagged or a little like looking like zigzag, a little rough. So yeah, because pixels are not a unit, like they're not a combined thing. Okay. So now what happens is anti-aliasing. So aliasing was your problem. Now anti-aliasing is the solution, like solving the or fixing the problems. Now what happens here is you are deceiving the eye. Like our human eye is really really dumb. So you're just fooling it, okay? So deceiving the eye by smart algorithms, like fooling the eyes with algorithms, with your making better rules of calculations, operations, better operations, or high resolution hardware, okay? High resolution hardware. If you have a better hardwares like my phone has 6 dots. Let's say your phone has 10 dots. 10 dots, more dots. So what happens right now is, if my phone would make lines like this would look more broken. If I introduce new dots in between, this looks more joined or continuous. So that's what happens when you increase your pixels or increase your resolution, number of pixels in a unit area. So yeah. By the way, you understood, right? Pixels are basic unit in a image, and like a resolution is the amount of light bulbs or pixels in an area. More number of it, high resolution. If you bring such hardware, so lines appear smooth because our human eye gets fooled because it looks it at a zoomed out way. Okay, so the cracks in the images doesn't get visible. Okay, it looks continuous, but it requires high processing time, CPU power to do the switch on and off, which I showed you here, to control that, and storage definitely, because that data also needs to be stored. This light on and off pattern charge should be stored in a memory, which is actually a charge storing device due to its magnetic properties. So that's gonna cost you. And this is pre-filtering or area sampling. There are many types of anti-aliasing techniques solving the problem. First one is pre-filtering, second one is post-filtering, third one is they're down here, pixel phasing. It is down here because you don't. It is not much relevant for you. Yeah, for us, let's say, it's not much relevant for us right now. It is much more advanced, so we are not gonna learn that right now. So our these two techniques have further techniques. So their basics means pre-filtering or area sampling means changing of intensity of light in pixels according to area, and this is super sampling. Obviously, Superman won't come here, but yeah, it divides the light pixels into high resolution subpixels. It divides, like, let's say it is a 1 pixel. It is a 1 pixel. It breaks it into further pixels. So now if we light it here, it will look much more better because it will join the broken pixels. That's what will happen. Understand? I hope you understand. So there is in pre-filtering you have unweighted, like it doesn't care about the center. Wherever light touches it, it would glow. Like wherever the object line touches, let's say. So what I have to explain you is, let's say this is a grid. Okay, this is a grid. Line touches here, 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 here. This will light it up all equally. But if it is it doesn't it is not biased, but when it is weighted it favors center more. So the more it is toward the center, let's say these parts, this would be more highlighted, this would be lesser highlighted because they're away from the centers. And here it is, it divides into subpixels. I told you zero line width is the more the line falls on the subpixels, more it is intense. Finite line width is, it thinks line as a a solid thing which passes, and the more it is inside the polygon, like this is inside the polygon, the more highlighted it is. It is just the version of zero is unweighted version, and finite line is weighted version, and pixel is just sophisticated version of finite line width. Because this also favors center, but it multiplies some factor, Gaussian factor. Like Gaussian is a differential factor, so obviously when you calculate differential, when you find limits, you obviously tend to approach slowly, then your line appears much more smoother. So it is the most advanced here because it multiplies a factor that favors the center. So obviously the addition of the intensities is the intensity of overall. So that's why it is much more simpler, like smoother. Okay. And what happens here in pixel phasing is we just shift the electron gun or the laser that is printing the image on the uh, this screen. We don't adjust the pixels by our maths, calculations, and intensities. Okay, we don't do that. We just simply shift the electron gun that lights up the screen, and it makes much more smoother, images. So yeah. That's what it was. Thanks for watching. Watch this one. Yes, see you next time. Bye. I guess it is visible one now. I brought the focus on the camera. I hope it is visible. Thanks for watching. Watch this one. See you next time. Bye. Okay, see ya. Bye. Wait a second. Is my hand visible? Yes.